In the 2013 video game The Last of Us and its 2023 TV adaptation, humanity is overrun by a mutant parasitic fungus called Cordyceps, which disfigures its victims and takes over their minds, turning them into violent, unthinking, walking mushrooms called clickers. But this horrifying premise is hardly unique. Indeed, the motif of infection and assimilation by an alien parasite crops up time and time again in popular fiction, from the 1950s novels The Puppet Masters and The Body Snatchers by Robert Heinlein and Jack Finney, and their numerous screen adaptations to the 1998 film The Faculty, and classic episodes of The X-Files, Star Trek The Next Generation, The Outer Limits, and Futurama. And no wonder, horror fiction often reflects universal anxieties, and parasites have been an unwelcome part of the human experience since the dawn of time. From the tapeworms and hookworms that infect our guts, to the filarial worms that cause elephantiasis, to the single-celled protozoa that cause malaria, sleeping sickness, river blindness, and other horrible diseases, these biological infiltrators have been, and still are, responsible for a great deal of human suffering the world over. And while the mind-hijacking parasites of popular fiction may seem like gross exaggerations created for the sake of chills and thrills, that's not the case, for such creatures are horrifyingly real. For example, Cordyceps from The Last of Us is based on the actual parasitic fungus of the same name that infects ants and other small insects, hijacking their minds and bodies and turning them into mindless slaves with one single purpose: to spread their new master's spores far and wide. Indeed, such devious puppet masters are remarkably common in the natural world, being found in nearly every habitat and family of life, including our very own bodies. This is the story of the real-life zombie makers, the most horrifying and fascinating creatures on Earth.
Just before we get back to Simon discussing the horrifying world of mind-controlling parasites, you know what else is a bit like a parasite? Data brokers who quietly collect and sell your information without your consent. Last month alone, Google put out an urgent warning that over 2.5 billion Gmail users may have been affected by a Salesforce cloud system exposure of their account information. TransUnion also suffered a major breach affecting almost 5 million people, exposing addresses, date of birth, phone numbers, social security numbers, etc. Literally, a month does not go by where multiple such breaches exposing a massive group of people's data doesn't happen, and then often populated into databases by brokers who deal in such information, and finally available to anyone who wants to buy it. So if your privacy is important to you, as it is for Simon and I, that's where today's sponsor Delete Me comes in. Delete Me is a subscription service that relentlessly hunts down your personal data on hundreds of those shady broker sites and gets it removed. When you sign up, you get a detailed privacy report showing exactly what they found and where it got deleted, and within weeks your info starts disappearing. I've been using Delete Me for about a year and a half now. In that time, they've flagged my information on around 100 broker sites that had things like my home address and phone number listed for anyone who wanted it. Each time, Delete Me pulled it down and, importantly, kept monitoring it so it didn't pop back up. Basically, they've been playing whack-a-mole on my behalf with zero effort from me after a quick initial setup. So if you're ready to take back control of your privacy with minimal effort, now's the time. Use our link joindeleteme.com/TIFO and promo code TIFO to get 20% off all consumer plans, or just scan the QR code on the screen. Now let's get back to Simon discussing the fascinating world of mind-controlling creatures.
Now, before we get started, we should take a moment to examine what a parasite even is. Merriam-Webster's dictionary defines a parasite as an organism living in, on, or with another organism in order to obtain nutrients, grow, or multiply, often in a state that directly or indirectly harms the host. Parasitism is typically contrasted with regular predator-prey relationships in which one organism simply kills and consumes the other outright, and more beneficial relationships like symbiosis or mutualism in which both partners benefit, and also commensalism in which one partner benefits and the other is unaffected. By this definition, bacteria and viruses, well known for infiltrating and feeding off their hosts, should also be classed as parasites, but they rarely are. The term usually is reserved for eukaryotes, organisms whose cells store their genetic material in a separate nucleus. If this division between parasites and non-parasites seems somewhat arbitrary, that's because it is. It's a byproduct of the long and messy process by which naturalists and biologists discovered, defined, and assembled the various branches of the tree of life. Indeed, the term parasite far predates its application to biology. Deriving from the ancient Greek parasitos, or next to the food, the word originally refers to priests who tended to the food during temple feasts before evolving into a derogatory term for a toady or hanger-on, one who attempts to curry favor with a wealthy or powerful individual by providing gifts goods and services. Typically, the social and biological definitions of parasitism remain strongly intertwined with knowledge of and disgust for one feeding back into the other. Even the great Charles Darwin, father of modern evolutionary theory, looked down upon parasites, viewing their distasteful lifestyles as evidence against the Almighty's ordered and benevolent hand in the creation of life. In an 1860 letter to American naturalist Asa Gray, he wrote that, quote, "I own that I cannot see as plainly as others do, and as I should wish to do, evidence of design and beneficence on all sides of us. There seems to me too much misery in the world. I cannot persuade myself that a beneficent and omnipotent God would have designedly created parasitic wasps with the express intention of their feeding within the living bodies of caterpillars, or a cat that should play with mice." Though Darwin's writings made no such claims, Victorian naturalists soon came to view the process of biological evolution as one with an underlying goal and direction, from lower to higher organisms. All organisms, they believed, were locked in a perpetual struggle to improve and perpetuate their own kind and dominate inferior organisms, aka the nature red in tooth and claw, or survival of the fittest model, and as an aside, neither of these phrases originated with Darwin as is commonly believed. Nature red in tooth and claw first appeared in the 1849 poem In Memoriam AHH by Alfred Lord Tennyson, while survival of the fittest was coined by British anthropologist Herbert Spencer in his 1864 book Principles of Biology. According to the model, organisms were capable not only of evolving into higher forms, but also backsliding or degenerating into lower ones, with parasites, which traded in independent existence for living inside and feeding off of their hosts, being the most degenerate of all. This view found perhaps its greatest advocate in British biologist Sir Edwin Ray Lancaster, a family friend of Darwin and director of the London Natural History Museum, who, in his 1879 book Degeneration, a chapter in Darwinism, wrote, quote, "Let the parasitic life once be secured, and away go legs, jaws, eyes, and ears. The active, highly gifted organism may become a mere sac, absorbing nourishment and laying eggs, just as an active, healthy man sometimes degenerates when he becomes suddenly possessed of fortune, or as Rome degenerated when possessed of the riches of the ancient world. The habit of parasitism clearly acts upon animal organization this way." End quote. And as should probably surprise absolutely nobody who knows anything about the Victorians, these principles were enthusiastically and unscrupulously imported into other fields such as sociology and politics, where they were used to justify oppressive and racist social policies. A Scottish biologist and evangelist, Henry Drummond, wrote in his 1883 pamphlet, Natural Law in the Spiritual World, quote, "Parasitism is one of the gravest crimes in nature. It is a breach of the law of evolution. Thou shalt evolve. Thou shalt develop thy faculties to the full, thou shalt attain to the highest conceivable perfection of thy race, and so perfect thy race. This is the first and greatest commandment of nature." But the parasite has no thought for its race or for its perfection in any shape or form. It wants two things, food and shelter. How it gets them is of no moment. Each member lives exclusively on its own account, an isolated, indolent, selfish, and backsliding life. All those individuals who have secured a hasty wealth by the chances of speculation, all children of fortune, are victims of inheritance, all social sponges, all satiates of the court, all beggars of the marketplace, all these are living and undying witnesses to the unalterable retributions of the law of parasitism. End quote. Now, over time, others carried this rhetoric to ever greater extremes, with one thinker writing in 1925 that, "In the struggle for daily bread, all those who are weak or sickly or less determined succumb, while the struggle of the males for the females grants the right or opportunity to propagate only the healthiest, and struggle is always a means for improving us." This is Hitler, isn't it? This is Hitler. It's Hitler! And struggle is always a means for improving species' health and power of resistance, and therefore a cause of its high development. The Jew is only and always a parasite in the body of other people's. I told you it was Hitler. That he sometimes left his previous living space has nothing to do with his own purpose, but results from the fact that from time to time he was thrown out by the host nations he has misused. His spreading is a typical phenomenon for all parasites. He always sees a new feeding ground for his race. And if all that seems eerily familiar, those indeed are the words of everyone's favourite failed art school student turned mass murderer Adolf Hitler. Yet so potent and versatile is parasitism as a social metaphor that its use is hardly limited to racists and fascists, with Marxists and other left-wing theorists commonly applying the term to landlords, business owners, and others whom they believe leech labour and wealth from the lower classes. And despite the depths of depravity and horror to which the Nazis carried the notion of social parasitism, the idea stubbornly persists persisted even in scientific circles for decades after the Second World War. In 1955, American biologist Howard Stunkard used now outdated models of parasitism to argue against the New Deal policies of President Franklin D. Roosevelt, writing in an article titled Freedom, Bondage, and the Welfare State that, quote, "Since zoology is concerned with the facts and principles of animal life, information obtained from the study of other animals is applicable to the human species. When other food sources were insufficient, what would be easier than to feed upon the tissues of the host? The dependent animal is proverbially looking for the easy way. It may be applied to any group of organisms and is not intended to refer merely to political entities, although certain implications may be in order. Such a welfare state exists only for those lucky individuals, the favored few who are able to cajole or compel others to provide the welfare. The well-worn attempt to obtain comfort without effort, to get something for nothing, persists as one of the illusions that in all ages has intrigued and misled the unwary." End quote. And even as late as 1989, the great animal behaviorist Konrad Lorenz continued to conceive of parasitism in terms of degeneration, writing that when we use the terms higher and lower in reference to living creatures and cultures alike, our evaluation refers directly to the amount of information, of knowledge, conscious or unconscious, inherent in these living systems. If one judges the adapted forms of the parasites according to the amount of retrogressed information, one finds a loss of information that coincides with and completely confirms the low estimation we have of them and how we feel about them. The mature parasite has no information about any of the peculiarities and singularities of its habitat. The only thing it knows anything about is its host. A retrogression of specific human characteristics and capacities conjures up the terrifying spectre of the less than human, even of the inhuman. Today, however, biologists understand that the old Victorian notions of fitness, sophistication, and higher and lower forms are meaningless when applied to the real natural world. After all, the fundamental goal of any organism is to spread one's genes as widely as possible. Thus, any organism which succeeds in its goal is, by definition, fit and well evolved, whether it be a mighty redwood tree or a thin film of algae soaking up sunlight, or a sponge or sea anemone filter feeding on the ocean floor, a koala or sloth sitting in a tree eating leaves, a lion hunting antelope on the Serengeti, or even a tapeworm living in that lion's gut, absorbing nutrients from its host's every meal. As a result, in recent years, the much maligned reputation of parasites has started to be rehabilitated as biologists discover just how sophisticated these supposedly degenerate organisms can be. But perhaps this shouldn't come as a surprise, for parasites occupy some of the most hostile environments on Earth, the dark, chaotic, and disorientating bodies of other organisms, where legions of immune cells are constantly attacking in a tireless bid to drive out the foreign invader. Indeed, the traditional division between parasites and other pathogens like bacteria and viruses may not be as arbitrary as it seems, for the greater sophistication of eukaryotic cells allows them to evade, manipulate, and even defeat their host's immune systems in ways the bacteria and viruses could only dream of, making most parasites immune to traditional medical interventions like vaccines and antibiotics. A classic example of such immune system manipulation is carried out by Trypanosoma brucei, the corkscrew-shaped protozoan or trypanosome that causes African sleeping sickness. Spread by the bite of the tsetse fly, trypanosomes change the molecular composition of their outer membranes every 10,000 divisions or so, such that no sooner has the host's immune system geared up to fight one form of the parasite than the invader has already moved on to another. This constant game of bait and switch accounts for the vicious cycle of improving and worsening health characteristics of sleeping sickness and often results in the victim being killed by their overstimulated immune system. Plasmodium, the protozoan that causes malaria, pulls a similar trick. After being injected into the host by the bite of an infected mosquito, the worm, Plasmodium larvae, or sporozotes, travels through the bloodstream until it reaches the liver, where they penetrate liver cells and multiply into thousands of spherical forms called merozoites. These are then released into the bloodstream, where they take up residence inside erythrocytes or red blood cells. Here, the merozoites grow and multiply before bursting out to infect other red blood cells. Once in a while, they will produce pairs of male or female gametocytes or sex cells and release them into the bloodstream, where they can be sucked up by another mosquito. Inside the mosquito, the gametocytes combine to produce oocysts, which hatch into sporozoites, and the whole cycle begins anew. Being little more than hemoglobin-stuffed membranes with little genetic material of their own, red blood cells are unable to signal their infected status to the host's immune system, making refuges for Plasmodium to hide and multiply in. However, to prevent its cozy little home from being destroyed by the host's spleen, the parasite constructs a series of latches on the cell's exterior to anchor it to the wall of the blood vessel. Unlike the plain wall of the red blood cell, these latches can be seen by the host's immune system, which duly begins assembling an army of antibodies and immune cells. However, as with Trypanosoma bruci, by the time this army is ready, Plasmodium has already switched the molecular composition of its cell latches, pulling from a large arsenal of genes specifically evolved for this purpose. In this manner, Plasmodium always stays one step ahead of its host. Even more sophisticated and daring is Leishmania, a nasty protozoan transmitted by the bite of the sandfly, which causes leishmaniasis or espundia, a horrifying flesh-eating disease whose effects can range from a small open sore to the victim's entire face being eaten away. Lovely. Unlike Trypanosoma and Plasmodium, which are constantly on the run from their host's immune systems, Leishmania, like the Joker in The Dark Knight, deliberately turns itself in as a part of its evil plan, allowing itself to be ingested by an immune cell called a macrophage. Now, normally, macrophages encase the pathogens they capture in a bubble called a phagosome, which is then fused with another bubble called a lysosome, full of special enzymes that cut apart and kill the pathogen. Leishmania, however, releases special compounds to prevent this fusion from taking place, allowing it to hide unmolested right in the heart of the macrophage. The parasite also releases other compounds which cause the host's immune system to favor the production of helper T cells over inflammatory T cells, rendering the immune response even less effective. But few feats of immune manipulation compared to that performed by a species of parasitic wasp known as Catesia congregata. These wasps prey upon the tobacco and tomato hornworm, the larval forms of the Carolina sphinx moth, Menduca sexta, and the five-spotted hawk moth, Manduca quinquemaculata. The adult female wasp lands on a caterpillar, stabs it with a long syringe-like structure known as an ovipositor, injecting her eggs into its body. After 2 to 3 days, these eggs hatch into larvae, which anchor themselves to the inside wall of the caterpillar's hemical or body cavity. As an aside, it is worth noting here that insects, like all arthropods, have an open circulatory system, with hemolymph, the arthropod version of blood, circulating around the open hemical rather than a closed system of blood vessels. In this position, the larvae feast on hemolymph while breathing air through a tail-mounted snorkel protruding through their host's skin. Now, ordinarily, the caterpillar's immune system would be more than capable of wiping out such invaders, but along with her eggs, the mother wasp also injects the host with a pair of biological weapons. The first is a special kind of cell called a teratocyte contained within each egg. When the eggs hatch, the teratocytes start growing and releasing hormones which arrest the normal development of the host, preventing it from spinning a cocoon and metamorphosing into an adult moth and suppress the action of its immune system. The other half of the wasp's biological payload is even stranger and more insidious, comprising millions of specialized viruses. A typical virus consists of a strand of DNA or RNA encased in a protein sheath, which latches onto the surface of a host cell and injects its genetic payload into the cell's interior. There, the viral genes hijack the host cell's molecular machinery, reprogramming it to produce more copies of itself. Eventually, the cells burst open, releasing a swarm of new viruses, which then go on to infect more cells. While wasp viruses work in much the same way, they lack the genes necessary to replicate themselves. Instead, these genes are carried within the DNA of the wasp itself, with viruses being produced in special calyx cells within the wasp's ovaries. Once inside the caterpillar, the viruses attack the host's immune cells, causing them to burst or clump together and rendering them unable to attack the wasp larvae. In other words, the wasp infects the host with a form of caterpillar AIDS. But as these viruses cannot replicate themselves, they are eventually used up, and after around 8 days following oviposition, the caterpillar's immune system returns to normal. By this time, however, the wasp larvae have matured enough that they are able to withstand all further immune assaults without their mother's help. This symbiotic relationship between parasitic wasps and these viruses is a remarkable one. Viruses already blur the boundary between life and non-life, and the debate still rages over whether they should be counted as actual organisms. But given their inability to reproduce and their total dependence on the wasp host to survive, these viruses stray even further from the definition of life and may be more accurately thought of as genetic delivery systems rather than organisms in their own right. And once again, to learn much more about the bizarre and fascinating biology of viruses, please do check out our previous video, Are Viruses Actually a Form of Life? Anyway, Cordyceps manipulations don't stop at simply tanking the caterpillar's immune system. By interrupting its regular molting cycle, the wasp larvae allow their host to grow up to twice its regular size, giving them more food and more room in which to grow. The parasites also alter the way in which their host processes its food. Normally, caterpillars convert the leaves they eat into fat, allowing them to store up energy for their long metamorphosis inside their cocoon or chrysalis. Infected caterpillars, however, convert their food directly into sugar, which is more readily absorbed by the wasp larvae. And in a final indignity, the larvae causes the caterpillar's reproductive organs to shrivel up, conserving even more energy for the parasites to siphon up. The wasp larvae undergo 2 molts over the course of 12 to 16 days, whereupon they burrow out of their host's body and spin cocoons on its back. At this point, the caterpillar's behavior changes dramatically. At the larvae's command, it suddenly stops eating, likely to prevent it from devouring the wasp cocoons, and instead of finding a shelter place to spin its own cocoon, it just stays put on a leaf. Then, 4 to 8 days after spinning their cocoons, the mature wasps emerge and fly away, leaving their now hollowed-out husk of a host to finally give up the ghost. But as diabolical as Cordyceps congregata is, it is far from alone. There are estimated to be 1 million species of parasitoid wasps worldwide, all specializing in a wide variety of hosts. Some belonging to the genera Pepsis and Hemipepsis even target tarantulas. Different species employ different breeding strategies, with some being coinobionts, injecting their prey with venom before laying their eggs and allowing their larvae to devour their paralyzed but still living host from the inside. Again, lovely. Others use the same strategy as Cordyceps congregata, with some taking the exploitation of their hosts to even grislier extremes. For example, the related species Cordyceps glomerata, which preys upon the cabbage worm caterpillars Pieris brassicae and Pieris rapi, puppeteers its host into actively guarding its pupae while they are developing into adult wasps. After they've completed their second molt, the wasp larvae burrow their way out of the caterpillar's abdomen and weave cocoons on the surface of the leaf below. The zombified caterpillar then weaves a protective net over the cocoons and stands guard as they develop, lashing out and spitting noxious fluids at any attackers who wander too close. And if all of this is starting to sound eerily familiar, that's because parasitoid wasps served as one of the main inspirations for the xenomorph in the classic 1979 film Alien and its many sequels. But as spine-chilling as the life cycle of parasitoid wasps might be, nothing can compare to the sheer existential horror wrought by another parasite, a truly alien crustacean known as Sacculina. Though classified as a barnacle, Sacculina looks nothing like the creatures that commonly encrust piers or ships' hulls. In its larval form, the creature is only a few millimeters long and looks rather like a common organism called a water flea, with a teardrop-shaped body, 8 fluttering legs, and a pair of black eye spots. The female Sacculina larvae wanders the ocean until she comes across her preferred host, Carcinus manus, aka the European green crab. She then lands on and crawls along one of the crab's legs until she reaches a soft joint, whereupon she sheds her exoskeleton and injects her soft insides, known as a ketrachon, into the crab's body. Sacculina then begins to grow, sprouting root-like tendrils that spread throughout the host's body, wrapping around its internal organs and absorbing nutrients directly from its hemolymph. Once under the parasite's control, the crab's physiology changes dramatically. It stops molting, and it loses the ability to regrow severed limbs, activities that would draw precious resources away from Sacculina. The parasite also sterilizes a host, replacing the abdominal brood pouch of female crabs with a knob-like growth in the same location. Male crabs get the same treatment, with Sacculina altering their physiology to make their hosts' abdomens wider and flatter, like a female crab's. When a male Sacculina larva finds an infected crab, it lands and crawls towards the female parasite's abdominal knob, where it finds a pinhole-sized opening. Then, like the female before it sheds its exoskeleton and injects itself through the hole, coming to rest in a chamber within the female's ovary, where it fuses itself to the wall and begins generating sperm. Most female Sacculina have 2 such chambers, allowing them to host 2 different males with which to fertilize their eggs. Normally, pregnant female crabs tend diligently to their brood pouches, keeping them clean of algae and parasites. Then, once their eggs have matured, she climbs up onto a rock or other high spot and bounces up and down to release them into the current, waving her arms around to further stir up the water. Crabs infected with Sacculina perform the exact same actions, only the eggs they expel are not their own, they're the parasites. While still technically alive, the infected crabs are, from an evolutionary perspective, functionally dead. Sterile, mind-controlled zombies reduced to only a single function: to help their new masters breed and find new hosts to infect. This horrific puppeteering so disgusted Victorian naturalists that Sacculina directly inspired Sir Edmund Lancaster's influential and tragically pernicious theory of degeneration. But as with the Cordyceps wasp, Sacculina is far from alone in its strategy, with many other parasites converting their hosts into mobile nurseries. For example, several species of the nematode worm family, Myrmidhidae, live as free-swimming adults in streams and ponds, but parasitize mayflies in order to reproduce. After hatching from their eggs, the nematode larvae seek out and take up residence in mayfly nymphs, which live underwater, before climbing to the surface, molting and flying away as fully formed adults. Famously, mayflies only live as adults for one day, the females scrambling to find a male to mate with. Once the deed is done, the females fly off to find a nearby body of water, land on a protruding rock or piece of vegetation, and dip their abdomens into the water to release their eggs before expiring. If the insect is infected with nematodes, then the fully grown parasite will force its way out of the host into the water, where it will mate, lay eggs, and start the whole process over again. Meanwhile, the male mayflies, once their task in life is complete, fly off landward to find some place to set down and die. This presents the nematodes with a tricky problem, as any larvae that happen to infect male mayflies will die along with their hosts. For this reason, Myrmidhidae pulls a similar trick to Sacculina, turning its male hosts into pseudo-females. Specifically, it alters the concentration of solutes in the mayfly's hemolymph, forcing the insect to seek out water and carry out female-like egg-laying behavior. This, in turn, allows the parasite to break out and escape into the water to breed. Nor is such puppeteering the exclusive purview of larger complex organisms like wasps, barnacles, and nematode worms. Even simple fungi can perform equally horrific hostile takeovers. The genus Cordyceps, which inspired the killer fungus in The Last of Us, comprises over 260 different species, which parasitize a wide variety of hosts, including houseflies, grasshoppers, and ants. But in every case, the playbook is the same. After falling onto their host's body, the fungus spores begin to grow, sending out Sacculina-like tendrils that wrap around their victim's nervous system and internal organs. At first, this infection has seemingly little effect, the host carrying on with its business as per usual. But then, the host is suddenly sieged with a powerful urge to seek out a high place, such as the top of a blade of grass. There it anchors itself fast, lifts its abdomen high, and freezes in place, allowing Cordyceps to erupt from its body and sprout one or more spore-bearing fruiting bodies. These spores are then released into the air, ready to infect further hosts, and the original host, its purpose fulfilled, finally dies. Even more insidiously, the fungus times its host death precisely in order to maximize its own reproductive odds. For example, species that infect common houseflies time their final exit for just before sunset, when healthy flies begin landing on the ground for the night, making themselves easy targets, and the air is cool and moist enough for the Cordyceps spores to quickly develop. And if all this is already starting to make your skin crawl, I am afraid that it's going to get so much worse. For many parasites are not content to merely turn their hosts into mobile nurseries, but instead callously use them as a disposable means of reaching their preferred host. For example, Leucochloridum paradoxum, aka the green-banded broodsac, is a species of trematode flatworm that normally lives in the digestive tracts of birds. In order to get there, however, the worm first infects a snail, crawling into and filling up the host's eye stalks. It binds the eye stalks and prevents them from being drawn into the body. The worm also takes over the snail's brain, puppeteering it into seeking out a high exposed place. There the worm, its green and brown striped body visible through the snail's translucent eye stalks, begins to pulse rapidly, imitating the appearance and motion of a caterpillar in order to lure the bird into eating it. That's right, Leucochloridum turns its host into a disco zombie snail, which, come to think of it, is a terrific name for a band. Once in its new host, the worm lays hundreds of eggs, which are expelled in the bird's droppings, falling to the ground to hatch and start the cycle anew. Other parasites are more subtle in leading their hosts to their doom. For example, in the 1980s, parasitologist Janice Moore of Colorado State University conducted a series of experiments on acanthocephalia, aka thorny-headed worms, which parasitize starlings by way of the small isopods commonly known as pillbugs or woodlice. In one experiment, Moore constructed small chambers divided into two contrasting environments, moist versus dry, shaded versus exposed, and dark versus light-colored gravel. She then released pillbugs, some infected with acanthocephala, into these chambers and observed where they congregated. As expected, infected pillbugs were far more likely to seek out more exposed, dangerous environments, suggesting that the parasite was manipulating them into being more easily spotted and eaten by their preferred hosts, the starlings. To confirm this, Moore conducted a pair of follow-up experiments. In one, she built a pillbug habitat on the floor of starling cages, while in another she set up starling nesting boxes in a forest and tied pipe cleaners around the nestlings' necks to prevent them from swallowing any food their parents collected. In both cases, while only around 1% of pillbugs in a given patch of forest floor were infected, up to 30% of those found in starling nests were. By this point, you may have noticed that all the mind-controlling parasites that we've covered so far infect other non-human organisms, mainly insects and other arthropods. But lest you think we are somehow immune from such insidious manipulation, indeed, at this very moment your body may be swarming with one of the most sophisticated parasites on Earth, a tiny single-celled protist called Toxoplasma gondii. Though few people have ever heard of Toxoplasma, it is frighteningly common, with an estimated third of the human population, some 2.6 billion people, being infected. Part of the reason the parasite has managed to go unnoticed for so long is the manner in which it both evades and manipulates its host's immune system to its own advantage. Toxoplasma is closely related to malaria-causing Plasmodium and follows a broadly similar life cycle, though it is far less picky about where it makes camp. Upon entering its host's digestive tract via contaminated food, Toxoplasma's egg-like oocysts hatch into sporozoites, which immediately develop into highly mobile tachyzoids. These burrow their way into the nearest cells, where they begin furiously multiplying. These cells eventually burst open, releasing a swarm of Toxoplasma into the host's bloodstream. This naturally triggers the host's immune system to start producing antibodies and other specialized immune cells. However, by this time the parasites have converted into another form called bradyzoids and are retreated into hard, cyst-like structures in the host's muscles and brain. As a result, the host may not even be aware that it's been infected by a parasite, suffering, at worst, some mild flu-like symptoms. But here, Toxoplasma faces a tricky dilemma. In order to spread, the parasite must produce more copies of itself, these copies emerging from their protective cysts and spreading throughout the host's body. However, if Toxoplasma multiplies unchecked, constantly triggering its host's immune system, it risks killing the host and itself in the process, as often happens with African sleeping sickness. Instead, Toxoplasma pulls off an ingenious trick, using its host's immune system to keep itself in check. It does this by releasing compounds that stimulate the production of inflammatory T cells, which wipe out all Toxoplasma organisms not safely inside their protective cysts. In this manner, the parasite and host live in a cozy equilibrium, neither harming nor eliminating the other. But while this arrangement works well under normal circumstances, it can go dangerously awry if the host's immune system is compromised by something like HIV. Indeed, until the widespread adoption of antiparasitic drugs and antiretroviral drugs to treat the underlying HIV infection, toxoplasmosis was one of the leading causes of death among AIDS sufferers. Another group of people highly vulnerable to toxoplasmosis are pregnant mothers. Fetuses, you see, have no immune system of their own, while the mother's own immune cells are forbidden from crossing the placental barrier. Otherwise, the mother's immune system would view the fetus, half of whose DNA belongs to its father, as a giant parasite and start to attack it. Thus, if Toxoplasma manages to enter the fetus's body, it will find no immune system to keep itself in check and multiply out of control, causing severe and usually fatal encephalitis, that is, swelling of the brain. Interestingly, while toxoplasmosis is commonly found in humans, its preferred hosts are actually cats, the parasites are cysts spreading via the cat's feces. This is the reason why mothers are warned not to clean kitty litter while pregnant. And now you know. And speaking of cats, just like Acanthocephalia and leucochloridum worms, Toxoplasma often finds itself inside an intermediate host like a rat or other small rodent and must engineer some way of reaching its final destination. The insidious way it accomplishes this was revealed in a series of experiments carried out in 2000 by Manuel Burdoy, Joanne Webster, and David MacDonald at the University of Oxford. The researchers built a large maze out of bricks, in each corner of which they placed a nesting box and a bowl of food and water. Each of these nests was, in turn, treated with a different scent. Fresh straw bedding, used bedding from a rat's nest, rabbit's urine, and cat's urine. Both healthy and Toxoplasma-infected rats were then released into the maze and their behavior noted. Normally, rats avoid the scent of cat urine like the plague. Indeed, when testing anti-anxiety drugs on laboratory rats, researchers often use cat urine to induce panic. Incredibly, however, the rats infected with Toxoplasma seemed completely unbothered by the scent, returning to the cat urine-treated nesting boxes. Mice subjected to similar experiments also exhibited reduced motor control and agility. These findings suggest that Toxoplasma deliberately alters its intermediate host's behavior, making them more brash, foolhardy, and likely to be hunted down and eaten by a cat, the parasite's preferred host. When this happens, the bradyzoids occupying the cysts in the prey's muscles emerge and develop into yet another form called merozoids, which multiply rapidly inside the cat's intestines, mate with each other, and produce large numbers of fertilized oocysts. These, in turn, are expelled in the cat's feces, ready to be accidentally ingested by an intermediate host and start the whole cycle over again. Alarmingly, Toxoplasma's psychological manipulations may not be restrained to rats and mice. In a series of studies conducted since 1992 at Charles University in Vinnytsia in the Czech Republic, both healthy volunteers and those infected with Toxoplasma were subjected to the Cattle 16 Personality Factor, or 16PF questionnaire, and the Cloning Temperament and Character Inventory, or TCI personality test. These surveys revealed statistically significant personality differences between infected and non-infected individuals, though men and women were affected in different ways. For example, infected men tended to be more reckless, expedient, and vigilant, and less rule-abiding, while infected women were more outgoing and moralistic and less vigilant. Other studies have found measurable decreases in motor coordination, as well as a significantly higher risk of developing schizophrenia, getting into a traffic accident, and even of committing suicide among infected individuals. Weirder still, toxoplasmosis has also been linked to anxiety disorders, higher preference for unconventional sexual practices such as BDSM, and the adoption of more tribalistic conservative political beliefs, with Jaroslav Fleger of Charles University going so far as to suggest that the parasite might even be partially responsible for the recent global rise of right-wing political movements. As with the rats in the Oxford University experiments, the behavioral changes wrought by Toxoplasma seem geared towards getting its hosts, that is, us, killed and eaten by cats, but unless you live out in the wilderness or your house cats haven't been fed in days, this scenario is unlikely to play out in the parasite's favor. Still, that such a common parasite, previously believed to be harmless, might in fact be partially responsible for the giant mental health crisis and socio-political dumpster fire that is the world today, well, it's truly a chilling thought, isn't it? Disturbing and bizarre as they may be, the examples we have covered so far in this video barely scratch the surface of the weird and wonderful diversity of parasites. For instance, parasitism is hardly limited to just insects, worms, fungi, protozoans, and barnacles. Many plants, like mistletoe and broomrape, also live parasitically, drawing their water and nutrients from a host plant. Other organisms are social parasites, exploiting their hosts from within. One well-known example is the cuckoo, which lays its eggs in the nests of other bird species. The baby cuckoo then manipulates its new parents into feeding and caring for it, usually at the expense of its adopted siblings. Nor have we covered the extraordinary array of defenses that host species have evolved in order to fend off parasites. For example, certain caterpillars forcefully catapult their feces long distances to prevent parasitic wasps from tracking them by scent. Other species, once infected, go on a mad breeding spree, scrambling to produce as many offspring as possible before the parasite sterilizes them. Still others, such as chimpanzees, actively fight back by consuming plants with medicinal properties which help flush parasites out of their bodies. And finally, far outside the scope of this video is the outsized impact parasites have on the environment and the history of life itself. While Victorian biologists dismiss parasites as the degenerate runts of the natural world, it now appears that these devious opportunists may, in fact, be among the most important and influential organisms on Earth. For example, by weakening certain individuals and making them more vulnerable to predators, it is often parasites and not traditional predator-prey dynamics which help keep populations of certain species in equilibrium. More fundamentally, parasites may be directly responsible for the evolution of everyone's favorite recreational activity, sexual reproduction. While organisms can, and many do, reproduce asexually, this produces a population of what are effectively clones, all of whom are equally susceptible to a given parasite or other pathogen. For such organisms, infection can spell quick death for entire populations. Sexual reproduction, however, allows the genetic deck to be constantly reshuffled, producing a genetically diverse population better able to withstand parasitism and other diseases. Going back even further, parasitism may even be responsible for creating complex life as we know it. The mitochondrion, which all of us will remember from grade school is the powerhouse of the cell, has its own genetic code distinct from that of the cell it occupies. Indeed, such mitochondrial DNA is often used to trace maternal ancestry through the maternal line. According to one theory, the mitochondrion was once an independent organism which at one point tried to parasitize a larger cell. However, this infiltration proved beneficial to both parties, and their cozy and productive relationship has persisted ever since. In more practical terms, parasites can actually be extremely beneficial to humans. For instance, fungi closely related to Cordyceps are used to produce the immunosuppressant drug cyclosporine, widely used to treat autoimmune diseases like rheumatoid arthritis and Crohn's disease, and to prevent rejection following organ transplants. And in the 1960s, 1970s, the accidental introduction of the cassava mealybug Phoenococcus manihoti from South America to Central Africa led to the widespread decimation of the staple cassava crop. However, in the mid-1990s, Swiss entomologist Hans Herren developed a means of using parasitic wasps dropped from aircraft as a form of biological control, successfully bringing the infestation under control. Similar interventions using other wasp species, as well as the Saculina barnacle, are currently being investigated to fight infestations of crop-devouring larvae and invasive European green crabs on the American West Coast. And that, viewers, is a brief look into the horrifying and very real world of mind-controlling parasites. If this video has made you want to duct tape plastic over all your windows and doors and never leave the house again, take comfort in the fact that even toxoplasma can only alter our minds in a relatively subtle way. As far as we know, there is no real parasite that can just latch onto our heads and make authors stay in the basement and research and write endless scripts. No, for that, we must resort to good old-fashioned chains and beatings. For now. Thank you for watching.
Just before you go, wanted to say thanks again to Delete Me for sponsoring this video. To get your personal data removed from data brokers across the internet, check out Delete Me via our link in the description and get 20% off with the promo code TIFO. Thanks for watching, and I hope you have a great day.